Hello there, today we'll be doing permutations, another backtracking problem. So this is our input and this is our output. We have 1, 2, 3, and what we need to output are all permutations possible. So with backtracking, what we're able to do is, remember, we go all the way to the end and we grab the first one. So how we do that is that we use an I pointer and the F pointer. That way, we can recursively move one at a time until the end and produce one output. So that's our first output. Okay, so now that that's done, we have completed that cycle. We move back here, and of course our I already completed the first cycle. Now we have to swap these two. So we have now 3 and 2. So that's another cycle after we move the F forward, and that we have nothing to change here after F and I is the same. So now that we're done with this, so we have 1, 3, 2, we have to backtrack and swap it back. So 1, 2, 3. And this is now complete after I has gone to the end of this particular cycle. So now we move F back down and we move I forward. With that, we can swap I and F again. So we now have 2 and 1. And now we, with that, what we're going to start swapping now is moving the F forward and itself. And that's going to be the same. And this is going to be the same. And now we have 2, 1, 3. With that, we have completed our F and our I. So we move the F back and we move the I forward from this particular position forward by 1, and we now have 2, 3, 1. And now we're done with that. Now we move back the F back to the first position after I has moved through to the end of 3. Now we swap the 3 and, well, of course, now we first thing, shoot, I messed up. So I forgot to roll it back. So that means that, so this 2, 3, 1 needs to be swapped. So we have a 2, 3, 1 here. And with that, we move forward with the F, and that completes this particular cycle. And now that F has gone to the end, we move back to this particular point, and we do the backtracking. So this is going to be 1, 3 again, and we backtrack one more time because we have returned, and now we have 1, 2, and 3. Now at last, F and I is at this particular point, so we swap the F and the I, the first point, and the 3 and the 1, and yeah, so we move the F forward. F is going to be at I. We start at I again, and we basically do this for each particular cycle. At each particular cycle, we're going to start at this particular point again, and we're doing the swapping. Of course, they're the same because we're not doing any swapping yet. And with that, we have 3, 2, 1, and we move back to this particular point. Move the I forward. Now we swap these two. Now with 3, 1, 2, and we moved the F and the I forward. Nothing to swap here. And now we have 3, 1, 2. Of course, this brings us back all the way here, and I is done. So we move back here. Well, I is done as well, and so now that's our last one, and we have our output exactly. So that's how we will be doing this problem with our backtracking. So first things first, we need to define our backtracking. And our first item is start at 0 index, and if first is equal equal to n, that means our length of nums, then result.append our nums at that particular placement. So we're going to do this for I in range first through n, and num first is going to swap with nums at I, which is equal to nums at I and nums first. With that, we can run backtrack to the next item, and that's going to swap the same item again and again like I showed earlier. With that, now we're going to do the backtracking phase, and we're rolling back, and we're going to set everything back up just as we have left it. So same piece of code. And with that, we can now, oh, this is not in the right placement. So now we can do n equals length of nums and results equals empty, and we run backtrack. And then we can return our results. Once we submit this code, we can go through the code once more and show how that is done. Of course, there is a typo. So just give this a moment, and we're good to go. So with this, let's go through this example one more time. So we're just going to go through 1, 2, 3. So 1, 2, 3, f and I begins at the same place. These two items go forward at the same time because this moves forward. So we, well, all right. 1, 2, 3. Same place, move it forward, move it forward, move it forward until the end. Now we're done. We have 1, 2, 3. And basically what happens here is that f and I, well, I is complete, so this is done. And now we move f back down. And we move I forward from the second position to the third position. Well, the second, well, if we're counting, let's just say third position here for easy context, or it's 0, 1, 2. It's the index of 2. And we swap these two, as you can see here, this line of code. And we'll move the first again forward. Is there anything to swap? No, there isn't. And that's it. And we swap the 2 and the 2, and we move forward once more time. And we're done here. So we apply 1, 3, 2. Now we roll this back. Of course, we swap 1 with 2, and we roll this back, and we swap 2 with 3. And now we are done. So with this goes to the end, and we move our f forward back at first item back to this point, and 2, and then we do this first swap for 2, and we start with 2, 1, 3, and we repeat the process over again. So this is a recursive process, which processes each item using this particular function, where we swap this item, where we don't swap anything first, but we start swapping from the end at each particular point. And you can see this happening here with this swap. As we swap forward, and each particular swap does that same process over again for each item. And the O of n process here is n to the number of, it's like n to the n power, the number of items to the number of times this is seen. So this is 3 to the third combinations, I think. That doesn't seem right. There's only 6 combinations here from 3 items. So I believe it is n to the n though, because of the backtracking, as you can see. We're doing every single permutation, so it's 3 times 2 times 1, And then after that, you'll have 4 times 3 times 1, and 5 times 3 times 1. That's the O of basically n times n if we register these as items, because each item has to go through this 5 times. So with that, we have solved this particular problem. If you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. Thank you very much. I'll see you in the next one.